doing number 59 here, and Shems is reading for me, so we have all the data we need. 59. All right, read slower.
A penny is placed at the outer edge of a 33 1/3 RPM record.
Stop. All right, so 33 1/3 RPM. Is that a frequency, a speed, or a period?
Frequency.
It's a frequency. All right, so frequency is equal to 100 thirds RPM. You guys okay with that? All right. Go ahead, Shems.
Radius equals 0.150 meters.
0.150
150.
meters. All right, so here's our radius. Okay? Go ahead.
A. What is producing the centripetal force that enables the penny to rotate along with the record? Kinetic or static friction?
All right, so friction. But is it static or is it kinetic?
Static.
All right. You guys say it's static, but it's moving. How can it be static friction if it's moving? All right, it's not moving relative to the surface it's on, right? So, that's it. Static friction. All right, so that's our answer for part A. Part B.
The centripetal force needed depends on the speed at which the penny is moving.
All right, centripetal force depends on speed. That is mv squared over r. Okay, but we know we could give speed in terms of period and frequency as well. So the question is,
how can the speed be determined from the data given?
oh, all right, so how can the speed be determined from the data given? All right, so if we've got, what do we have? We have frequency and we have radius. Okay, so how are we going to find the speed? What relationship are we going to use?
2 pi r I r.
Okay, so we know that 2 pi r over period is equal to velocity. But we also know that frequency is equal to what?
1/3 speed.
It's the reciprocal of period. So velocity is simply 2 pi r frequency. That's easy. Okay? That's part B. All right? So now, the next question is the problem. All right, and Shems, go ahead and read the problem again.
Account for your answer in each case. How can this speed be determined from the data?
Where it says problem.
Find the minimum coefficient of friction necessary to allow the penny to rotate along with the record.
All right, and why does mu matter? Because it's friction that's keeping it on the wheel, right? So, again, two-equation strategy. Net force has got to be, now let's give it in terms of frequency. All right, how do we give it in terms of frequency? Our frequency version of centripetal force, right? That's equal to m times 4 pi squared r f squared. Hopefully you remember that. If not, go back and review why that's true. That's a simple matter of substituting v is equal to 2 pi r f, right? Then what else? What do we got? The answer to that question, or that question is the answer to how much force do we need, right? What does that mean? How much force do we need to do what? To make a mass m go around in a circle of radius r with frequency f. All right? So where does the force come from? Static friction, which is equal to mu static times normal force. Again, we're on a horizontal surface. There's no vertical acceleration. If we draw a free body diagram, we can see that the normal force has to be equal to mg, with our centripetal force being static friction. Got that? So those are in balance, so we can say that n is equal to mg. So now when we do this, we're just going to be able to use our two-equation strategy and come down here and say that m times 4 pi squared r f squared is equal to mu static times, we're going to substitute mg for normal force. And our m's cancel out, making things rather convenient, yes? All right. So now we're asking, what is the minimum coefficient of static friction? Let's solve for mu static. Mu static is equal to 4 pi squared r f squared over g. Now let's do a quick dimensional analysis on that and make sure that it turns out. What should the units be for mu static?
Nothing.
Nothing. It's dimensionless. So we got f squared, a frequency. What are the units for frequency?
Revolutions per second.
It's hertz, right?
Good morning, Langley. Please stand if you're in the hallway stop for the Pledge of Allegiance.
That's it.